Okay, this is Zoom for construction surveying, Monday, April 6th, around 6:30. And we'll go through the homework that I graded for you on coordinate geometry, or COGO. So you should be seeing PowerPoint right now. And so this page, which was 7, and page 10 were the two pages that you had to submit for homework. Do me a favor, a couple of you submitted the entire PowerPoint, every slide. Just submit, if you would please, the pages that are required for homework. That'll be a big help.
It was just page 9, right?
This is page 9, yep, or slide 9 on the PowerPoint. So if you were late with this homework, actually, I don't think I took any points off. I think I did on the heavy civil, but not on this one. So
if we just posted a picture of our answer on it.
What's that?
Like we printed it out and then took a picture of our answer on. Is that fine too if we uploaded the picture?
Yeah, whatever works for you folks. The best thing that works for me is a PDF, because then it's only one file. But if you can't do a PDF, I'll definitely work with you with taking pictures off your phone. The one thing that I cannot access is the HIAA or HI something. I can access a JPEG, a PDF, a Word doc, and so on. I think it was in another course where they were doing this one file that wouldn't work. So, so try to get these in on time. I haven't decided. I got to talk to Mr. Van Duzen. I may, on Vanco Hall, when I put in the assignment due dates, I may shut down Vanco at the time that it's due. Because if you submit late work to me, I don't know that you've submitted it. I've got to go back through every homework to find the one that you did, because it's not necessarily in chronological or alphabetical order. So if you happen to be late and you find that the site Vanco is closed to submission, then you'll have to email it, and at least then I'll know that you have it. I will say that on note number 3 of my email with the notebooks or field books, there was an earlier assignment worth 25 points with a small checklist taped to your field book or your handout. And I told you I would I'd grade those as a resubmission. Send those via email. That way they'll come in one at a time. But a couple of you already emailed it to me, and I would ask, if you did, to please email it back to me, because I can't find it. And then I'll give me a day to look at whatever you email me on that field book, and then shoot me another one if you don't hear back from me on an upgraded or an updated grade. Okay. I want to make sure that I get all those done. I think I gave that offer till Friday, April 10th. A couple of you have extenuating circumstances. So if you know, let me know if that doesn't work for you. So without further ado, let's go to the answer key, which should be on your screen right now. And the northeast corner of the garage, it would be the garage that was part of POB 3. And so this is the northeast corner. Let's see if we can go with, there we go. So the northeast corner. Let's see, we'll go back to here. This was north 2002. So if you're going up 21.67 right there, then that's going to be 2002 plus 21.67, which is 2023.67. Whoops, let's see. 2023.67 right in there. Okay. The easting is the same. The easting for the northeast is the same as the southeast, right? Because you're running north-south, so the easting is not going to increase or decrease. So it's 4887.5. 4887.5. So there's our two, that's N2E2. We're doing all of our calcs at POB3, which we're calling N1E1, which in ancient Babylonian Sanskrit right here, what's that symbol for? Oh, let me do the,
Point of instrument.
The EDM.
yep. Right, so that's the symbol for the, you folks weren't using EDM, you were using the theodolite, but basically it's the instrument. So the instrument is at a, what's CP?
Control point.
It's a control point, and sometimes the symbol for control point, we use a delta, okay? So N1E1 is always where the instrument is set up over. It's a control point, or as we'll show you in the next example, some call it a WP, a working point. So there's your N1E1, and there's your plugging and chugging. Okay, E2 minus E1 is minus 12.5. And N2 minus N1, N2 minus N1 is 23.67. And then it's the arctangent or the inverse tangent of that value. Okay, so some of your angles were off. I'm not sure why. You may have given me an angle, say, from the baseline to the line of sight to the northeast corner. But that theta, that's just the Greek symbol theta. You've probably seen it in algebra. So that's a symbol for an angle. So in coordinate geometry, in quadrant 2, it's measured off of a line of sight from the instrument setup looking at Project North. Okay, these are little break lines. I didn't show the entire garage. And so red is the distance. And I think most of you got the distances. Most of you got the angles, just a couple of hiccups right there. Does that make sense or not? Any questions on that? So I think what we'll do is we'll probably throw a quiz at you next week after we go over some additional coordinate geometry homework. So it won't be this week. Okay. If we look at the southwest corner, okay, the southwest corner.
Hey, I got a question.
Yeah,
The we're basing our easting off the corner of Smith, right? The north 5,000 or north 2,000, east 5,000.
it's this point right here.
Yeah. So, how'd you end up with a negative 12.5 for your easting up there?
It's not an easting, it's a difference. It's the difference between the two eastings.
Oh, okay.
So N2E2 is always the point that you want to locate. N1E1 is always the point that the instrument is set up over.
Okay.
These are not northing and eastings. These are differences in the eastings and differences in the northings. Same thing here. Same thing here. Some of, and actually, I'm glad you brought that up. Some of you, I think on the, let me run that number here, 12.5 divided by, the hell is that, 23.67. There was something where you
Well,
didn't,
if you look on page 7, when you were putting down your formula, I think you put an extra square in there. And I think that might have been what was confusing people, sir.
let me
It's for the
see.
angle.
Page 7?
It says squared, and then you don't square it when you show your math.
Right where it goes angle equals tan -1, E2, E1 divided by N2, N1 squared. And that square, I think, is where people were getting the screw up right there.
Yeah.
Oh, I didn't put squared right there.
Yeah. Because then when you run the math, it only works if you don't square everything like that.
Good. Next time, if you guys see the typos, definitely there we go. Thank you. Good, good, good. So if we go back to this, so now we're at the southwest corner. Which is over here. So the southwest corner is going to have the same northing as the southeast, right? I'm running east-west, so I'm not increasing to the north or to the south. So this, for the southwest corner, the northing is still 2002. And the easting is the same as the easting for the northwest corner, because if I'm running this way, I'm running north-south, and the easting hasn't changed. So that's another way. If I give you on a quiz, if I gave you two opposite corners, that's the easy way to do it. So this one had the same easting as this one and the same northing as this point.
Yeah, that's how I found them.
Yep. And then this one has the same northing as this point right here and the same easting as this point. So if you go back to there, N2 minus N1 is 2, E2, and that should be a negative 40, right? That should be a negative 40, shouldn't it?
Yep.
That should be negative.
Mr. McKeegan, I got a question.
Yeah.
In the sketch where that green angle symbol,
Mm-hmm.
is that the angle we were finding? Because I originally thought we were finding that top left angle, like on that corner, the northeast corner.
Well, which one you talking about? This sketch or this sketch?
The top one, but I was looking at the top one, for example.
Well, yeah, so this is the northeast corner.
Mm-hmm.
This is the southwest. And the angle that you're getting is always off the line from your instrument looking north. If you were in quadrant, that's in quadrant 1 or 2, that angle is always measured off of the north.
Ah,
Okay?
yeah. Oh, we were looking at the angle
No.
on the other side of that red line.
No. Because we're at POB3 and our garage is over here.
Okay, I understand.
If let's say we were laying out the garage over here, still from POB3,
Mm-hmm.
that angle would be, say, to the northeast, it'd be over here. That angle would be from, this is your back sight, to your line of sight to the point that you want. So it's always measured Now it's always measured from the north-south line. In radial layout, when you actually perform the lab, you were getting those angles off of your baseline,
Mm-hmm.
but you weren't using coordinate axes. You weren't using coordinate geometry.
Wouldn't, for the southwest corner, wouldn't that be negative 87.14 degrees? Because that'd be a negative 40 divided by 2. So you're still
Yes.
going to have you're still going to have a negative coordinate there for where it's located, correct?
Yes.
All right.
So this would be negative, which makes this negative 40, this negative, and then that tells you that you had a positive difference in northing and a negative difference in easting, which throws you into quadrant 2.
Mhm.
Okay. Because again, what we did was we threw these coordinates. Remember these? In essence, you're throwing this same coordinate right here transfers over to your instrument setup point, and there's quadrant 1, 2, 3, and 4. So we're in quadrant 2. Quadrant 2, the difference in eastings is negative. The distance in northings is positive. So on any quiz, I give you this. Typically on any quiz, I give you the formulas. Hopefully I do them right. And I give you the quadrants, and you got to plug and chug the numbers. Okay. Now on this one, let's see, let me go back to this. So here's 87.14, and then that converts to degrees, minutes, seconds. 40.05. Somebody wrote, as far as the distance goes, you wrote 40 feet, 27 feet. Don't forget, you got to have accuracy out to at least hundredths of a foot. Okay. And then here on this page, there's just, I didn't grade this because, or I didn't take off because I only put on my handout that I wanted the other page. I didn't say I wanted this. So, but here's the POB 2 would be north 2000, east 4945. Okay. So is that, is it starting to make a little sense? I made up another worksheet, a very easy one to go over. Do you have any questions on this one? While you're thinking, this one right here is on Vanco. And let me see if I can find that. Are you seeing my Vanco Hall sheet?
Yep.
Okay. So right here, it says Kogo Coal Yard. So you want to download that one. Take a second or two and download that, or you can just look on the screen as I go through that. So did that. Now, so let's go to the coal yard. Remember this? Shoot, what did I do with that? Let me look that up here. Okay, so you might remember it from this. So I took this, you had, we went over how to lay it out. Remember you had like working points and so on. This little building right here. No, actually it wasn't little. Had a 30-foot deep foundation, and then an underground conveyor came up from its basement up out of the ground. So there's the building, there's the tunnel exiting at daylight, if you will. And then the 2 coal storage pads and the center stack pad. And then there's some more photos of it. So just to give you a little, view here. Okay. So now I've given you this. This is a real easy one. But it's also interesting because they do something that Mr. Van Duzen told us we shouldn't do, and he's right. Having negative numbers for a northing or an easting, and let me explain that. So we've got the same drawing. Now I've set up 2 axes again. That the green axes and the orange axes. Now the green axes we talked about. Oh, let me grab that thing. Gotta push it a little bit. So this is in the Word doc. So there's the green, there's the orange. Remember when we talked about setting up over the work point, backsighting that it was another working point in the rail, center line of the track. And then we talked about, remember this angle right here? That was a what angle? Remember we set up here, we backsighted, we zeroed. We did what to the telescope?
Used a deflection angle.
Yes, but
Correct.
what did we do? You're absolutely right. What did we do?
You had to dump it because you had to flip it 180 degrees.
Exactly. You literally flip the telescope. So now you're looking this way. You re-zeroed it and you measured 37.4057 degrees. And that gave you your line of sight along the center of that center stacker. That big beast that ran up and down and stacked it to either side of the, to either coal storage pad. So this was set up using radial layout.
You kind of lost me there. I'm kind of confused as to what you're talking about just then.
Well, where? So what you got to do is you tell me where am I set up right now?
North 0.00.
Nope.
Working point 1.
Right. So my instrument's at working point 1, and this is what we did when we went over this in the pit.
Okay.
So you're set up here. Now what did I do?
Backsight.
Backsight what?
That green point and 0.00.
No, that N00 is this line right there.
Oh, okay.
Okay, that's not a any point has a northing and an easting. This actually has a southerly and an easting, but don't worry about that. But we called this, we may not have called it working point 3 when we talked about it about a month ago. But I'm set up here. I backsighted here.
Mm-hmm.
Okay. And then what did I do? Before I do anything to the instrument, once I establish my backsight, I get the vertical crosshair lined up with the point. What do
Zero it?
I got to zero it. Yep, good. Then one of you folks said, hey, you're going to dump the telescope, which means what?
Yeah, I don't know what that means.
Okay, good. See, that's where, and I'm glad you asked the question. What I want you to do is interrupt me at the second that you're not sure what I'm talking about.
Yep.
So And I got to figure out a way. Do I have my total station? Shit. My total station's upstairs. Let's see here. Telescope rotates, the telescope pivots on the frame of the theodolite, or the theodolite total station transit, whatever you want to call it, right? So I literally take the telescope and I literally just turn it. I flip it. I don't change its, I don't change the horizontal movement of the total station. I literally just, I flip the telescope. So instead of looking this way, if I flip it, I'm now looking 180 degrees the opposite way.
Okay.
Did I explain that okay?
Yeah, that makes sense.
Next time I'll bring my, I'm writing myself notes. I'll have the EDM with me because I got mine here.
All right. Another question. If you were like in the field, how do you choose that backsite point particularly?
The designer gives you the control.
Okay.
These examples, and actually I'm going to give you a great one. It's probably the hardest one yet. We're going to talk about it in a minute. You're going to lay out the Burger King in Vestal, New York. Okay?
Mhm.
And you're going to have to figure out what the designer gave you for control. And it's not very good, but it exists. So these are established by the designer for the contractor.
Okay.
What a lot of contractors do for big jobs is they literally hire a surveyor, not the one that the designer necessarily used, but they'll hire a surveyor to come out and check all the control to see if in fact the bottom of that rail is in fact 695. They'll check all the coordinates of these points to see if they work. And that's what I did. I worked for an environmental design firm who had their own survey crew who established all of these points for the project. And then the contractor comes in, either uses his own field personnel or hires a surveyor. So again, when you dumped that, you flipped that telescope, you're now facing this way, you re-zeroed it, and you measured that little degree, that little angle right there, 37.4057. And so now you're looking up this point. So let's go back to, so now I'm on this. So this was used for radial layout, just like you did in Smith Hall. A baseline with really no consideration for north, south, east, or west. So that's those are the green axes. Okay. Now the orange axes are now being used for coordinate geometry. And what I did in this handout is I typed in the working points. See where it says working point 1 right here? All of this is hard to read, so this is it. So this working point, which is that label, which is that point, now has a northing of 63.73 and easting of 10,861.89. I believe they made these up. And they did not do, I would not have picked the numbering system that they did, and we'll show you that in a minute. Working point 3, now instead of northing, it says south. It's like, what the hell do I do with that thing? We'll show you that in a minute. So that's south 9.61, east 19191.84, elevation bottom rail 695.00. Never put plus or minus on a design. That's bad. You want that dead on to hundreds. So those are 2 working points. There's another working point within this unloading building, and it's used for the conveyor, but it does not give any northings and eastings. Someday I'll show you that when you come back. There's another working point 4. It's the center line of the yard conveyor drive pulley. There's its northing and easting, and I typed them in for you. And I put the 2 red asterisks. And here's my ancient Babylonian Sanskrit that says WP4, working point 4. Okay. So what I'm asking you to do, whoops. What the hell am I asking you to do? Let's see here. So what I'm asking you to do is I want you to highlight. If you can't highlight, and if you can't print it out to highlight it, that's okay. But highlight north 00 and north 500. This line is running which way? This is grid north.
So it's running east.
Right here is grid north. This is, they called it true north. It might even be magnetic north. So this is the grid that we're using. What's another word for grid north? You saw it in another project.
Project North.
Yeah, I just gave you the answer, Project North. Okay, so sometimes you'll see it written as grid north, sometimes Project North. Okay, so this is grid north. I'm running east-west. So any point along this line has the same northing because I'm only moving east or west. And so what the designer said, we're going to call this north 0. Why the hell they did that is beyond me. The air base may have set up their own grid system. I don't know. I'd have to look at that. Here's north 500. Okay, that's north 500. Running east-west. Every point along there has a northing of 500. What is the distance from here to here? As I move
500.
500. It's almost too easy like that. So that's from here up to here is 500 feet. So again, they're setting up a coordinate axis. This is east 10,500. This is east 11,000. So the distance running east-west from this line to this line is 500 feet. Does that make sense? So you're breaking it up into a grid. Okay, now this is going to be your homework, and I haven't decided when to assign what. So after we go over all 3 of these assignments, you can help me. We'll come up with something that everybody is comfortable with based on your other workload. Because I don't know what your other workload is, and I don't want to load you up all at one time. I'd rather spread this out over a whole week. So, what's that symbol right there? Because I typed it in and that's the symbol pi, but what do I use it to symbolize?
Machine.
My instrument, my transit, and my EDM. Back in the day, it was an old engineering transit because from what I can remember back in 1983 when this project started, I think they just had the old transits, no electronics. So my instrument's at working point 1, so N1E1. This is now N1E1. Okay. If I want to determine the angle and distance to working point 3, okay, here's where your final answer is going to go, and here's where you're going to set up your formula. All I want you to show me is the formula looking like this. That's all I want to see. I don't need to see this. All I want to see is this.
The distance formula.
And the angle formula.
Understood.
So all I want to see is this plus the answer. This for the angle, this for the distance. Okay. Actually, shit, you know what I want to see? Sorry about that. Show me N2 minus N1. Literally write it out. Don't show me the difference. So show me N2 minus N1, what they actually are, squared, and then E2 minus E1. And in the future, I'll do my examples like that. And so the angles, you'll see E2 minus E1. Did I not square those either? Damn it. I'm losing it.
We all are.
Let's see here. My angles might be wrong. I'll bet they are. Squared. I gotta look up the book here. Give me 2 seconds to look this up. Oh, guess what? They never are squared. You guys got to keep track of me better. I'm going to throw it back at you. So, let me find my PowerPoint. Yeah, there's no squared. Only squared on the distances, folks. Sorry about that. I wonder I didn't square them. Okay. Yeah, that's right. So yeah, these wouldn't be squared. It's only the distances. So you're going to show the formula. You'll show for distance. N2 minus N1 squared plus E2 minus E1 squared, square root of that whole beast, and then give me the number for the angle and the quadrant. There's your final answer. There's the formula. Now, how many of you used the Excel?
I did use the Excel. I guess I didn't realize I was staring at the wrong numbers and I had to put in the numbers. That was kind of dumb, but of me to think that. But then I used them a little bit, but I didn't finish it all.
Well, keep playing around with these. Now, what I've done, and I don't think I've updated Vanco, you still have the one that does not show this coal yard. But all you got to do is say, go to the tank farm, 19. And we didn't have 4 groups, or just pick one of the groups because you can pick anything. Pick that and go coal yard. Although, let me, I don't know, did you ever done this with Excel? If you go like this, on the upper left-hand corner, see how I left click that? Control C, and you go over to any new sheet, go back to that same, not A, not 1, but right here, and it highlights the whole thing. Then Control V, there it is. So you can play around with that and either create a brand new worksheet or just, I'm going to delete the whole worksheet. So you can use anything, any of these numbers, because, you know, we haven't used them yet out in the lab just because we're not out in the field. So I set up a new coal yard. N1E1 is what? Working point 1. There was my 63.73, 10,869. Let me get this.
861.89.
Yep, 10,861.89. 63.73. I'm just checking myself to see if I did it right. Okay, and let's say that we want working, let's do working point 4 because that's easy first. Okay, so what is the, so let's go back. What's the northing for working point 1? Anybody? Bueller?
For working point
Do it,
1
damn it.
was the 63.73.
Well, for working point 4,
Oh, and then it's 681.13.
681.13, okay? What's the easting? 10,342.68. There's my, so there's your answers. There's your distance. There's your angle in decimals of degree. It's in quadrant 2. Makes sense because if this is working point 1, it is up and to the left, if you will. A negative difference between the eastings, a positive difference between the northings. But look at this one right here. The distance is 806.698. If I go to this, see these dimensions here? Not that 4-footer, because that's the end of the end of that is the end of the concrete, but that working point is 4 feet in. So if you add up all of these subdimensions, look at that. These guys must have been communists because that's 25'7" and 105 1 7/16. We don't like those, do we? All of that should be in feet, tenths, and hundredths. But look at that. I added them up. The distance from working point 1 to working point 4 is 806.70. And our XL was 806.698, which is the same as 806.70. So that's going to give you your answers. So all you got to do, you're going to have the answers. What I'm going to look for is, did you set up the formula right? So let's do working point 3. Now working point 3, what is its northing? Let's go number 20.
Wouldn't it be a negative number?
Exactly. Because it is what? It is below.
0.
It's below.
It's south.
Where the hell is that? There it is. I can't find that. It's below north 0. That's why it has a south. Right?
Mm-hmm.
So this is going to be negative 9.61. And its easting is 11,191.84. And there's your answer.
Wait, Mr. McKeegan, I'm confused why you put, it said S 9.61. Why did you put that as N in the N1 column?
No, I put it as negative. And that's
Oh,
what.
okay. Oh, I get it now. Okay. Thanks.
That's okay. Mr. Van Duzen was telling us that, remember when we first established, and I said it was north 5,000, east 5,000? The reason we went with that is so that we didn't have negative numbers. What they did is they said, this is north 0, but our working point 3 is south of that north 0 line. So that's why they called it south 9.61. They could have said north negative 9.61.
Ah, okay.
Good question. But I like the fact that this example exists because it can show you that you can get into negative numbers. They're a pain in the ass, but you can get into negative numbers with coordinate geometry. And I'm not an expert of this, but man, I'm learning a lot, especially in this textbook. I'm having so much time on my hands. I'm reading more. Ugh. Anyway, so that's going to give you your answers. There's your angle. There's your distance. Okay, 338 feet away, and so on. Now, one of the things that I didn't put as an assignment is the angle that we calculated from working point 1 to working point 4 is measured off of the what? This is your back sight. Okay, that's your back sight. So that angle, what the hell was that thing? Damn it, I gotta go back and get that. Let's see, that angle is 40 degrees and some change. Let's say it's just 40 degrees, make the math easy. So this is 40 degrees right here. And this is 37. We'll just call it 37, even though it's 37.4057. So 40 and 37 is what? 77. So what is the angle from the center of the track to this line?
13.
13 degrees. Okay. So you can coordinate it with the radial layout using these axes. But here's another good thing. What's the angle measured from working point 1 to working point 3? Because that was in quadrant what? 2. No, quadrant 4. Right? Working point 3 is in quadrant 4. Makes sense. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So guess what that 77, right around 77.5 degrees, where's that measured from? What's your back sight? Now it's looking south. So you're set up here, you're going to look south, and you're going to measure 77 degrees to the line of sight from working point 1 to working point 3. In the book, or in the, what time is it? In the Vanco email that I sent you, did I put it there? I think. What you want to start doing is you want to start trying to visualize this stuff, and it's the hardest thing to do, especially because we're not in the lecture hall and we're not in the field. This is going to be part of the hands-on that we're going to do when you come back. Okay? We're literally going to do a bunch of coordinate geometry. We're going to bring my laptop out and we're going to burp out all these numbers. Okay? So try to visualize what you're doing as you're standing out there, right? Before this was built, working point 1 was in the middle of that track. Working point 3 was in the middle of that track. Working point 4 was just out and set in the ground, okay, as a control point by the designer. Although they probably only gave you this point and made you set this one, because they have to give you a minimum of how many points for horizontal control?
2.
2.
2, okay? So try to visualize what you're doing out there. Go back, you've got pictures of this. Go back and try to visualize building this damn thing. It was pretty neat. I wish I knew more about Kogo. I didn't know what the hell it was back then. So, you know, it's a very powerful layout tool. So that should be an easy one to do. Okay. And then you want to confirm these distances and angles with the Excel. Okay. So that's one of the homeworks. The other one, really easy, but another good boundary case study. This actually happened. Taking all the names off. I think I got all the names off. My God, if I didn't, I should have. So owner number 1, and this is also on Vanco. It says RMPLS, named after my good friend Ron Mullinex. Owner number 1 buys a 5.611 acre parcel without a boundary survey. They only had a deed. What is the difference between a deed and a survey?
Deed's a rough estimate, basically, of your property line.
Well,
The survey is like gives you the answer.
a survey is a map. A deed is a written description. Okay, a deed is a written description. And the two should give you the same lot. Okay, but the map, the boundary survey map, gives you a visual, if you will. So this is that person's property, bounded by these purple lines, 5.611 acres. He decides to build a house on the north side of the 50-foot right-of-way. It was called Fist of Funk Boulevard Extension. That's a nice name. The house, the well, the driveway, and the shed are all built. Owner number 2, who owns, now this little green line is a property line. It's not bold like this because owner number 3, we don't really, doesn't come into play. But owner number 2 owns from here, whoops, damn it, from here over to here. Again, owner number 2 owns here. See how I'm going here? Over to here. There's owner number 4. And owner number 5 owns everything on this side. So owner number 2 is an absentee owner. Never shows up. That land is vacant. So he shows up in a couple of years, and what's on his property? Half the house,
House and a shed.
most of the driveway, and the well. So this area right here in shade, this shaded area, is blown up. This is a 1 inch equals 100-foot scale. I've taken some liberties with it, so it's not exact. If you were to print out on 11 by 17, it would not be exactly that. But this little shaded area is blown up right here, and you can see just what the issue is. So this is your homework. Describe 2 red flags that might have prevented this mess. Describe the solution based on the survey map. Describe 2 other possible solutions. So have some fun with that one. So that's the second homework. Okay. I got one more of these. It's a PIP. Okay. This one's a PIP. Whew. Burger King layout. Okay. Did I give you the paper copy of this?
You gave us a paper copy of the 10 steps to figure out
Right.
backside.
Okay, so disregard those 10 steps because I've changed it. Where it says 10 steps on your handout is now this. Okay? So this is an actual Burger King in Vestal, New York. And one of the students years ago brought me the drawings. One of which is this drawing, C3. Civil 3. Civil drawing number 3. So here, this is the actual
Yeah.
Burger King. Okay. Here's the Burger King. Here's the drive-through, which we're all using now. There's the drive-through. Sycamore Road is right here. Sycamore Road's here. Ash Road. Ash Road. Okay. So what I want done is part 1 and part 2. Okay. Because I want to talk about this a week from tonight and then assign part 3. Okay. So part 1, make a sketch of the site that shows the horizontal control used to lay out the 2 corners of the Burger King building. The sketch is to be drawn in your field book. If you don't have your field book, draw it on a lined piece of paper. Hint, did the designer use control points set by a surveyor or coordinate geometry or distance from property lines? And the other hint is find the 2 corners that the civil drawing shows measurements to. No freehand sketches. It's got to look nice. Okay. So you're going to make a sketch and you're going to show all the information that you need to locate the 2 corners of the Burger King. So is it this corner, this corner, this corner, or this corner?
Can I ask what you want specifically included in the sketch? Like the actual, what's the word? Distances and like on a grid, is that kind of sketch? Or do you want like the triangle that I'm thinking of?
Triangle.
Like I'm just saying triangle because we did a homework off a garage and off a house before. And that's constantly what I think of.
Well, if they use control points, are you talking about the control point that has a triangle as its symbol?
No, like okay, so when, I don't know if you remember when I turned in my homework to you, I must have not drawn things right because I wrote like I had triangles like instead of the grid layout. I don't know. I'll come up with a better way to ask that in a minute.
Well, take a picture of it and email it to me. Do that right
Okay.
now.
All right.
What I'll do is I'll try to answer your question, then I'll take a look at your email. So your
Okay.
sketch, you got to go into the civil drawing and you got to figure out where they located this building, how they located this building based on either control points set by a surveyor or a designer or coordinate geometry. Do you see any northings and eastings? Do you see distances from property lines? So you got to figure that out. And then every bit of information that you need to locate this Burger King, you got to show on your sketch. So you're
Okay,
you're
I
going to
got it.
show you might show roads, you might show property lines, you definitely are going to show the Burger King.
Okay, that definitely helps. Actually, you answered my question.
But send a picture of that anyway, because I'd like to see that just in case it's it might give me another idea. Just tell me when you email it.
Okay, let me go find that.
Wait, so are we getting like another piece of paper, and like what should the homework consist of, like altogether?
Do you have your field book?
Yeah.
That's what you're going to draw it in.
Okay. And then
Right.
just
Did
the
I say
questions
that?
on the paper, and that's it. Or the questions in the thing you
This
sent.
sketch is to be drawn in your field book. Some of you still have your field book at here at Delhi Tech because you can't get your stuff. My kid can't get his stuff from Albany either. It's like, you got to be kidding me. There's 3 rolls of toilet paper there too. Shouldn't have said that, but it's funny. Oh, come on, you got to laugh about that. Jesus.
Absolutely.
So I told my kid, I said, well, just use the Wall Street Journal. But I'm going to first. Whoa, let's get away from potty humor. So if you don't have your field book, then you're going to, you'll just put it on a lined piece of paper as if it were a field book. Okay? But
Okay.
basically, you know the right-hand side of the field book is where you put your sketches. So I want a really nice sketch. Part 2, on that sketch, what's the benchmark in elevation? You got to find that on drawing C3. And then once you submit all that homework, then we're going to we're going to talk about part 3 a week from tonight. After I grade your homework, get it back to you, put in a sketch, and then we're going to talk about how you lay it out. And that's the part that you got to visualize. And that is not easy. So, in the assignment on Vanco, yeah, right here. Here's the reading in the textbook. And one of you emailed me and you got me thinking, which is nice. I want you to flip through pages 19.1 to 19.20. Just flip through them. As you flip through them, take a look at what makes sense. Make a little check. You know, does this sketch make sense? Does that make sense? But when you start on pages 19-21 to 19-38, these are methods for layout, horizontal layout. Check out the pictures, and read the procedures. He does a lot of nice step-by-step procedures. Most of these methods, or at least some of these methods, should look familiar. Try to visualize what he's talking about, because in the procedures, and I got to figure out a way to get my tablet set up so I can show you the book. So let me look at the book right now. Yeah, some of his procedures, he actually shows you setting up over the point. Yep, there it is. Page 19-26, right? He's literally set up over a point. Okay.
Is there any pages in the textbook or anything on Vanco that would help us like directly with this homework?
Do you have the book?
Yeah, the textbook, yeah.
These.
What
Okay.
if we don't
Yeah, I
have
was,
a
I was making sure.
What was the other question?
What if we don't have our textbooks? I don't have a textbook.
You know, if you know somebody who can send you some pictures, if you don't have it, you're still going to be able to get through this stuff. It might be a little more difficult, but you got to get on the buddy system
Okay.
and just start talking to one another. I think you know each other at least well enough where you say, hey, you know, say, who's got the book and can you send me a couple of pictures? Stuff like that. Here's another good one. If you have your ResCon book, right? CNST 110, the tiny house course. That book, Carpentry by Floyd Vogt, who used to teach here at Delhi Tech, check out chapters 27 and 28. They're they're on surveying for basic residential. Get some really good pictures. That'll help you a lot.
Mr. McKeegan.
Yeah.
Those are concrete.
Oh, wait, so one of these assignments going to be due?
Well, that's what we're going to talk about right now. But somebody just said chapters 27 and 28 are concrete. I don't think so. 27. No, 27 is chapter 27 in the Floyd Vogt book, Carpentry. Didn't you have to buy that for ResCon?
Yes.
Hopefully you kept it. If you didn't, I wish you had. If you didn't, not the end of the world. Chapter 27 is leveling and layout tools. 28 is laying out foundation lines. Okay, they show Joe Pythagorean's theorem. Very basic layout. Some really good. He goes in another chapter. I know we've talked about it. Oh yeah, leveling. That chapter 27. If you're still struggling with differential leveling, like the laser level, he does a really nice job on that. Don't forget that he uses feet and inches. We use feet, tenths, and hundreds. So use that book. Okay, now we got another couple of minutes before the heavy civil folks join us. I got 7:38. Perfect. So here's, can you see my Vanco Hall?
Yeah.
Layout, boundary line, case study, Kogo coal yard. Now, how about, and you got to, I'll put this on Vanco, but I just got an email from somebody in another course, statics. You know, they didn't realize something was due. There's 140 of you. Some of you are counted twice because you're taking 2 courses from me. Some of you are taking 3. I feel bad for you. That was a little joke. I can't keep track of 140 of you. Don't make me, I don't want to have to get tough on late stuff, okay? Give me something on time, please. You know, just be on time. I'm trying to make this fairly, you know, I'm trying to make it fair. So having said that, let's see, what's today? Monday, Wednesday, Friday, Sunday. What do you think of boundary line case studies? Probably the easiest. If we have that, you want a day or two in, you want a day in between these or 2 days? In between each assignment being due.
2, please.
2 days, please.
2
Okay.
days.
For you godfather and godmothers, that never comes out right. We'll call you all godfathers. Okay. So we're going to call the boundary line is due Wednesday at 11 p.m. Okay? The next one, the next easiest one, I think, is the coal yard coordinate geometry because you have the Excel to use. We'll make that due Friday at 11 p.m. And then the Burger King is due Sunday at 11 p.m. Now
Which one's due at 10? I mean, Friday.
the coal yard, which is the coordinate geometry.
It's due at 11.
Yeah, and I'm gonna post these.
Okay.
So here's the boundary. That's due Wednesday at 11. The Kogo, don't forget to use that Excel. It's going to give you the answers. The Kogo is due Friday at 11. Again, you're getting 2 days in between each one. And then the Burger King is due Sunday at 11. Okay. How's that sound? Is that fair enough?
Yeah, thank you.
Sounds good.
Thanks.
Yeah, like I said, you keep me posted on your workload. I'll work. I'll help you. And then next week in lecture we'll go over these answers, and then we'll go over. I'm going to be working with Mr. Van Duzen on another coordinate geometry problem that you're going to be doing in lab when you get back. Okay. The college has not decided when to do that. I'm not sure when they're going to decide. Everything is up in the air right now, as you know. So, but keep reading the Wall Street Journal. Now, I got 742. And hopefully, let's see. Anybody from Heavy Civil? Let's see. Mr. Davison, are you here from Heavy Civil? Damn it. That's a no. Is anybody here from Heavy Civil who is not taking surveying? Okay, any of you surveyors, any of you here that are not taking Heavy Civil?
Yep.
Yeah.
And who is that?
Ben.
Eric.
Okay, Delaney. Is Mr. Delaney here?
Yeah.
Mr. Hopkins?
Yep.
Mr. LaFond? How about Mr. O?
Yep.
So you guys, tell you what, let me do a quick attendance here. Is Armistead here? Armistead? Bueller? How about Bayonne? Is Bayonne here?
Yes.
Bonziglia?
Here.
Bryant? Hey, one of you guys mute it, will you please? Bryant, are you here? Ms. Bryant? This is taking too long. I'll put this on record. Actually, I should stop recording.
Just hit the participation where it says participants, then.
Yeah, but I don't feel like looking at it. It takes too long. Okay. So let's go into some Heavy Civil. Let me look at the record.
So surveying's done, or is it still surveying? How's that work?
Let's see. Good question. Yes, surveying is done. So
All right, take it easy, Mr. McKean.
take it easy, guys.
Thank you, Mr. Keegan.
Thank you, Ms. McKeon.
Have a
See you
night.
later.
Whoa, those voices just sounded like you are taking Heavy Civil.
I'm not.
Yeah, I know.
Yeah.
The only ones that should leave are Delaney, Hopkins, Bond, and Mr. O. The rest of you stay.
Have a good night.
Take it easy.
I gotta say, it almost felt like you're catching me leaving class early or something, like in the actual school.
Okay, so this is the CNST 150 Heavy Civil information. And one thing we're going to do is these are the answers for the estimating for the Smith Hall lab wall. This is the lab that we had you estimate. So you should be able to follow these numbers. What I would say is take a look at these numbers between now and we'll do another Zoom. I think I said another Zoom. When did I say it? Did I say it?
Thursday night.
Yeah, but I can't find where yeah, we'll do a Zoom Thursday night at 6:30. Again, I'll record it, so bring questions for this, okay? We're not gonna go through this because it's, I've kept you for an hour and a half already.
Wait, what time and when?
Well, it's 6:30 on Thursday.
Tomorrow, you said?
Thursday, the
Come on.
9th, correct? Just so I can write it
Yes.
on my whiteboard here.
Yes.
Yeah.
You guys gotta check Vanco every day for every class. I know it's a pain, just do it. Just check it. And get yourself a whiteboard like one of you just mentioned, or your phones. Put in reminders for your homeworks. I know this is a pain in the butt, but try not to get behind. So just come up, follow these, compare them to your answers, and come up with some questions. By Thursday, I'm going to have another masonry estimating problem ready for you. Okay? So going over some of these questions will help you for that new estimating. And the new problem is going to be a building that has not just regular stretcher units, but bond beams. And that's what we'll talk a little bit. I'll show you a little bit on the PDF that I've posted. This one right here. So come up with questions on for Thursday night. Anything that you have, any questions here? Like I said, I like the area method for estimating block. I think it's a hell of a lot easier. Here you're just getting the surface area. You're just getting surface area of the block, and you're multiplying it by 1.125 block for every 1 square foot of wall surface. Okay?
Is this answer key posted on Vanco?
Yes. Some of you have to read my my emails. A lot of your questions are answered on that email. Just do me a favor and read the email. So this is what you have now. It's a kind of a new lecture. Here's some reading that you need to do by Thursday for the next Zoom. Maida is the author of the textbook for this course. Again, if you don't have the book, you got to go on the buddy system. Just look at the pictures from all those 3 chapters, but chapter 25 deals with concrete masonry units, all the different types. And then the ResCon book that we talked about, right? Take a look at chapter 29, gives some good pictures of concrete block.
Mr. McKeegan?
Yeah.
I have an old copy of the ResCon book. Is the name of that chapter, please?
Let's see here. What do you got, the 5th edition?
I think so, yeah.
So chapter 29 is foundations and concrete.
Okay, thanks.
So part of that chapter on foundations is concrete block. Yeah, it's a good book.
I like it a lot.
It's a good book. I miss, like I said, the author taught at Delhi. I miss him. Good guy. So here, you've got this little building, and now we've got regular stretcher units. We've got corner units, right? The regular stretchers had ears on the block, if you will. The corners are for exposed corners. We have bond beams. We'll talk about open web bond beams. We'll talk about channel bond beams, which act as a or a lintel over an opening. Okay. And then just, we got dowels. We got a bunch of rebar. So this is up on that block. You got hollow core concrete plank roof. Should be roof plank. The masonry specs. In the Maida book, pages 8 and 9, is it's kind of like a chart. Actually, I put part of it on this handout on the specifications. The actual specs, if you go into Vanco Hall, for CNST 150, go under masonry, general information, and pump house Boston stuff. See where it says ET spec 04200 masonry? That's the PDF you need to do the homework.
Wait, where do we go again to get to the PDF? Is masonry general information and pump house?
I'm going back to it. I just had to. So you're in Vanco Hall,
Hmm.
masonry, general info, and pump house. Click on that. And here it says ET spec 04200 unit masonry.
Okay.
That's that PDF. And there it is. Now, each specification has 3 parts. Part 1 is general information.
Are we also going to have homework and heavy civil?
Yep.
Right.
Part 2 is products. You know, what type of brick, what type of block. Mortar, grout, joint reinforcement, ties and anchors, bent wire ties. And then part 3, it's coming here eventually. Part 3 is called execution. Another word really is, we call it a performance specification, a performance spec. Okay. So what are all these numbers right here? You've seen them on the concrete specs for ET. This is for the ET building. What are these numbers?
Line numbers.
Those are line numbers. So I'm going to ask you in the homework for either a paragraph number. So this right here would be this line this right here. If this were the answer, say concrete unit masonry to some general question, it would be line number 5. It would be at the lower right-hand corner. That's page 1 of spec 4200. So that's page 1 at the bottom of every page. Page 2 of spec 4200 unit masonry. So it would be line 5 of page 1, and the paragraph number would be 1.1 A1. And that's how you would write, say, an answer if it were that. So you got the line number, you got the page number, and you got the paragraph. Okay. Now the Smith Hall assignment, we only used regular stretchers. Now we've got all these different types of block, and that's what you'll get another assignment on Thursday, and you'll probably have 4 to 5 days to do that. When I give you that assignment on Thursday, you can come back with questions a week from tonight after surveying. We'll do that every night on Monday. Most of it will be surveying, maybe 20 minutes, half an hour will be block. Page 52 of the META book talks about industry organizations. These are extremely important when you get out in the real world. A lot of great sources of info. The 2 trade organizations we're going to use for masonry is the IMI, International Masonry Institute. There's the website. It's awesome. And the New York State Concrete Masonry Association is also awesome. You've heard of ASTM. There's also...
Did we buy the META book? What is that?
That's the book that you used for construction materials in your fall semester?
Yeah, the big building materials book.
Yep.
I have it.
META is the author. That's the name of the author. And also, you're going to use it you'll use it a lot for commercial construction in the fall. So we start out with the IMI website, click on Masonry Detailing Series, just play around with it. I had one that was a great view, and I said, well, I'll go back to it later. Now I can't find the damn thing. So If you see anything that you really like, send me a screenshot because I'm always looking for ideas. And here's a little synopsis of now dealing with a cutaway of a bond beam. And this detail, what do they call that when you're doing a term paper and it's a citation, right? So I took this from the IMI website. It shows a header, and now you're using a lintel or a channel bond beam. Okay, it doesn't have any cores, doesn't have any holes in it. It just looks like a channel. And it's used as a lintel over an opening. Okay, so these are the lintel bond beams. This right here. So you have both vertical rebar, but you got horizontal rebar that sits in these. Okay. This one right here is an open web bond beam, and it looks like this. And these are knockouts. And here, these have been knocked out in this picture because once you knock them out, you can lay what in there? Horizontal rebar. Because they have hollow cells, cores, if you will, you can also get horizontal rebar. So you got to know the difference between a open web bond beam and a channel bond beam. And that's where the wall gets its load carrying capability, because this is grout. It's not mortar, it's grout. Okay. And we'll talk more about the.
What's the difference though? Like because you knock those out, like the other ones are knocked. The channel beam is knocked out.
Is it basically when you knock all those out, it becomes a channel beam?
Yes. Yeah, when you knock these three out, it becomes this. But what's the big difference between this one and this one?
There's
The depth
no
of that
reinforcement
channel.
in the middle.
This one has no hole.
It has a base.
Those are called cores. C-O-R-E-S. So this one, it's hollow. This bottom part is solid. That makes sense?
Yeah, so like when would you use an open web and when would you use a channel? Like what's the difference?
Face or whatever.
Right here. So here this is just typically every 4 or 5 vertical feet of wall gets a bond beam. You're going to see that in what I'm going to give you on Thursday.
But like where's a situation where you could use a channel and can't use open web bond beam, or vice versa?
Right here.
Okay.
I mean, you could use an open, but you have to use like a 2x to keep the concrete from puking out the bottom, right? Through the holes.
Yeah.
But actually has an exposed, let's say that you didn't put in a header or you didn't put in a door or a window, and it was just an opening like Smith Hall. Right here. See, there's no door there. It's just an entranceway. So right there, that would be where the channel bond beam is a finished, it's a finished surface. The bottom of this, right? If you just left it open as an entrance like Smith Hall, you look up at it, the bottom is solid. Whereas this, it's got 2 holes in it. It's got 2 open cores. So that's where you got to get into that textbook. And you want to look at the META book and this IMI website and start getting familiar with these. But this is the channel bond beam is here, and you wouldn't use an open web here. You would not use a channel bond beam here because you want vertical rebar, right? Whereas here, there's no pores. in the bottom. And like I said, on the IMI website, there was a great 3D that you could rotate, and I just can't find it again. If I do, I'll send it to you.
Mr. McKeegan,
Mm-hmm.
where it says horizontal joint reinforcement, like what type of beam is that? Like what type of CMU block is that? Like right there, it's like a little, like it's like literally like a quarter of it, not even.
Well, what's the thickness of a mud joint?
3/8 of an inch.
3/8 of an inch. This is probably, what's a quarter, 4/16? This is probably 3/16 wire that literally fits in the mud joint. And a word for that is called Durawall. I'm going to bring over my...
But so that's neither an open web or a channel, correct?
It's
have to show you what's inside. It's not it's not.
Durawall is the name, and you'll see it in the book. When you start studying that book, you'll see it. So just keep studying this. Read the book, and it'll start to make sense. This is out of the book figure. It's in chapter 1, figure 6. So they call it figure 1.6. And this is the master format. Remember, it was the index of specifications. And so division 4 is masonry, division 3 is concrete, division 5 is metals. Remember, I use this to set up your notebooks. So over here, the first two, these are level 1 digits. That's the division. Don't worry about the difference between level 2 and level 3. Basically, all of these numbers, see, the division, all of these are what I call the subdivision. That's all you got to remember. So, in the spec, hey, that was nice. Hey guys, mute that, will you, for me, please? So 04 is the division, 200 is the subdivision. Okay. And then this is a page out of the spec. Remember we talked about the sentence number or the line number? I like line number better. This is the paragraph 1.1A1. And then remember at the bottom of the page, that's the spec, and then that's the page number. And then this is page 8 and 9 talks about this. We're just dealing with masonry right now. Now, you got masonry spec questions? List the master format division. So what I'm doing, these first two are easy. I mean, we already went over these. So what I've done is I've given you the page numbers. There's about 30 pages of that spec. And I don't want you to have to go through, let me go back to this. So I don't want you to have to go back through all of these pages. So I'm giving you the page number. I'm taking you right to the page number. And then I'm going to ask you, I should have written line number, but I wrote sentence number. And also the spec paragraph. That symbol right there is paragraph. And then, so all of this is due. These questions are due, let's see, Thursday we have a class. So let's have them do What do you figure? Thursday by 11 or Thursday by noon? Does that sound good?
Okay. Okay.
There's only 10 questions. Basically, you're going to write these in. If you have to, you can. You don't have to rewrite the questions if you can't make a copy of this to write on this. You can just give me the answers, but write down 1 through 10. And
What does it do?
thinking about, cold weather requirements, unit compressive strength, the unit masonry, the rebar, the masonry cement, the construction tolerances that we'll talk about in lab. Okay. So that's, and then this is the next building that I'm going to show you. This is a project. I'll show you the drawings for it. That'll be on the new PowerPoint for Thursday. And you're going to estimate. It's just a little block building within a much bigger building. Okay. So there's the spec questions. Any questions? Oh, on number five, very briefly, I actually answered 2 of them for you. So you can see just how briefly, if you look at that spec paragraph, there's like A through G. I answered A and F for you. So go to page 2, paragraph 1.3a, and you'll see that that's really, you're just going to briefly list the submittals required. In other words, the contractor has to submit information before they can start the masonry work. They have to do it for every part of the project. Okay? So I did a couple for you just to show you how briefly I want you to, you don't have to write the whole paragraph, in other words. Okay? Any questions?
Yeah, I was just looking at my CMU assignment I turned in, and I didn't give you my calcs because I did them on a sheet of paper. If I give them to you, can you bump my grade up a little more?
Send them, no promises, send them to me by email.
All right. I realized I probably did some of them a little wrong, but they're all here.
Well, I'm going to look at what was stated in the original requirements, and I'll go from there. Okay.
Alrighty.
Thank you. Yep. Any other questions?
So both homeworks that you assigned are due Thursday?
What are the both homeworks?
You said this one, and then before you said there was another homework due.
What?
Are you confusing it with the surveying homework?
I might be.
Yep, I think you are. The only masonry the masonry homework is reading, plus this these spec questions and the read.
Oh, so then this is the only homework that we have.
Yeah. Well, plus
Okay.
read. You got to. Yeah. You really want to do that reading because that'll help you out a lot. Okay. What I'm going to do is I'm going to stop recording. Any other questions?
No.
This Thursday, just to be